When you look up at the night sky, the moon appears to be a constant companion, yet it hides a fascinating secret. Regardless of its phase, the same dark patches and craters always face Earth, leading many to wonder if it is stationary. For centuries, observers on the ground have gazed at the same lunar features, never seeing the mysterious far side of the moon. This consistency might lead you to believe the moon is simply hanging in space, completely frozen in its orientation toward us. However, the reality of celestial mechanics is far more dynamic and involves a complex interplay of motion and gravitational forces. In truth, the moon is in constant motion, rotating on its axis at the exact same speed it orbits our planet. This synchronization takes about 27 days for both actions, effectively locking one side of the lunar surface toward us forever. To visualize this, imagine you are turning as you move, but your friend only ever sees your front, never catching a glimpse of your back. The moon behaves in a very similar way, performing a perfectly timed dance that masks its rotation from our perspective. This phenomenon, known as tidal locking, is the result of billions of years of gravitational interaction between Earth and its satellite. These forces gradually slowed the moon's initial, much faster rotation until it reached this perfect, stable, and permanent cosmic rhythm. But the story of the moon does not end with its face. There is an entire hidden side waiting to be explored. Many people mistakenly call it the dark side of the moon, implying that it never receives any sunlight at all. In reality, the far side receives just as much solar illumination as the familiar side we see from our backyards. It is simply the side that faces away from our planet, remaining forever obscured from the view of terrestrial observers. It wasn't until 1959 that humanity finally caught a glimpse of this hidden terrain through the lens of a spacecraft. The images sent back revealed a rugged, crater-filled landscape that looked remarkably different from the Maria we know so well. This discovery challenged our understanding of lunar geology and highlighted the stark contrast between the two sides of the moon. Yet, even with this knowledge, we must ask if we ever truly see more than just one half of the surface. The answer is nuanced, as the moon's orbit is not a perfect circle, which introduces a slight wobble called libration. This gentle rocking motion allows us to peek slightly around the edges of the moon over the course of a month. Because of this, astronomers can observe about 59% of the lunar surface from Earth, rather than exactly 50%. This extra view provides a valuable window into the lunar environment, even if the majority remains hidden from our eyes. Beyond just our own moon, tidal locking is a fundamental concept that helps us understand gravity and planetary motion. It has helped scientists explain how moons interact with their host planets throughout the vast expanse of our solar system. In fact, many other moons orbiting gas giants like Jupiter and Saturn are also tidally locked to their respective planets. The physics that govern our moon are universal, acting as a blueprint for understanding orbital dynamics across the entire galaxy. By studying this cosmic synchronization, we gain deeper insights into the gravitational history of our own neighborhood in space. The moon always shows the same side to Earth, not because it is stationary, but because it rotates with precision. This perfect timing, forged by billions of years of gravitational tugging, keeps one face permanently turned toward our home planet. So the next time you look up at the moon, remember that it is performing a perfectly timed celestial dance. It is a testament to the invisible forces of gravity that shape the movements of everything in the night sky. While it appears unchanged to the naked eye, the moon is a dynamic object governed by the laws of physics. Its locked state is a reminder of the long, slow evolution of our solar system and the stability of orbits. We are fortunate to have such a clear view of this process, which serves as a laboratory for celestial mechanics. Every crater and every dark patch tells a story of a history written in the language of gravity and motion. As we continue to explore the moon, we uncover more about the forces that have influenced its development over eons. The mystery of the moon's face is a gateway to understanding the broader mechanics of the universe we inhabit. It bridges the gap between simple observation and the complex scientific principles that define our place in space. The synchronization is so precise that it feels intentional, though it is purely the result of natural physical laws. We are essentially witnessing a gravitational equilibrium that has been maintained for a significant portion of cosmic time. This balance is not just a local curiosity, it is a fundamental aspect of how moons and planets coexist. By observing the Moon, we are looking at a masterclass in orbital stability and the power of tidal forces. Each phase of the Moon provides a new angle, yet the underlying structure remains constant and reliable for us. The dark patches, known as Maria, are ancient volcanic plains that have been preserved by this unique orbital arrangement. They serve as a historical record of the early solar system, protected by the Moon's locked orientation toward Earth. If the Moon were not tidally locked, our view of these features would be constantly changing and far less predictable. Instead, we have a stable reference point that has guided human navigation and culture for thousands of years. The Moon's influence on Earth, from tides to light, is amplified by this consistent and rhythmic orbital behavior. It is a silent partner in our planet's journey, always watching and always maintaining its steady, locked position. As we look toward future lunar missions, we will continue to learn more about the far side and its secrets. Every piece of data we collect reinforces the beauty and complexity of this gravitational dance we observe nightly. The Moon remains a source of wonder, inviting us to look closer and ask questions about the universe's mechanics. Its locked face is a constant reminder that even in the vastness of space, there is order and rhythm. We are part of this system, connected by the same gravitational threads that hold the Moon in its place. Understanding this connection allows us to appreciate the delicate balance that sustains our own planet's unique environment. As we conclude our look at this phenomenon, let us carry with us a new appreciation for the lunar cycle. Next time you see the Moon, you will know the story of the dance that keeps its face turned toward us. While many people refer to the hidden half as the dark side, that label is actually a common scientific misconception. In reality, the far side of the Moon receives just as much direct sunlight as the side we see from Earth. It is simply the side that faces away from our planet, keeping its rugged terrain hidden from our view for eons. Humanity finally glimpsed this mysterious far side in 1959, when a Soviet spacecraft captured the very first photographs from space. Those historic images revealed a landscape surprisingly different from the familiar, cratered face we have studied for thousands of years. Though the Moon is locked in its rotation, it is not perfectly still, as small orbital variations known as libration occur. These slight wobbles allow us to peek around the edges, letting observers on Earth view about 59% of the surface. This celestial dance is not unique to our Moon, as tidal locking is a common occurrence throughout our vast solar system. By studying these patterns, scientists gain vital insights into the fundamental nature of gravity and the history of planetary evolution. Ultimately, the Moon's permanent gaze is a testament to the long-term influence of gravitational forces shaping our local cosmic neighborhood. It turns a simple night sky observation into a profound lesson on the clockwork mechanics that govern our entire universe. The next time you look up, remember that the Moon is performing a perfectly timed, billions of years old dance around our planet.